Alrighty, the math dealer here, and we're going to break through some more logarithms. Maybe we'll even cut through them. Okay, so the key thing you always want to remember is that the log of any number to any base can always be rewritten as the base raised to that power equals that square or that box, right? So just a few things. The number down here is called the base. We got that, right? This number in here, or this term I should say, is called the argument. But in my world, I like to refer to it as the log, and yes, I really think it's going to stick if we say it enough times. Okay, so this base right here will always be the base of your exponential. The term that we're taking the log of, also known as a logand, is what this thing is going to equal, what this expression is going to equal. And of course, the triangle is your power. Love it. All right, now we have some other properties that we want to kind of break through. All right, and one of them is the sum of two logarithms. So if I take the log of x base b and add on the log of y base b, lo and behold, it's going to be the log of the product of xy base b. Key here is that these bases have to be the same. The next thing is our quotient. So if I have the log of x minus the log of y, so I'm taking the difference between two logarithms, it's going to become the log of the quotient, which is the division between the two logands. Yep, I said it again. You know I'm going to stick with it. Then, of course, I have the log of any base, log of x with any base, with a number out front. That being multiplied out here actually is going to turn into the power on, wait for it, yes, on the logand, and this becomes x to the p. So these three properties really do help you simplify logarithms. It helps you solve logarithm equations. It actually can help you rewrite some logs in terms of other logs. And that's what the next couple slides are going to show you how to do. So it's basically going to break down these properties in action. Fair enough? So here we go. All right. So you're given a few informational things here, right? You're told the log of 6 base 5 is A. You're told the log of 9 base 5 is B. And you're told the log of 4 base 5 is C. And then your job is to rewrite the following logarithms in terms of A, B, or C, or just a good old-fashioned integer. All right, so here we go. I have the log of 24 base 5. So you look at these numbers, and it's really kind of like a detective thing, like you're being clever, like you're being like, okay, so what makes 24? There's lots of numbers that make 24. But now look at the numbers that we're actually given. We're given a 6, a 9, and a 4. So what makes 24 with those? Well, if I had 6 times 4, I would get 24. So we know that. We know that 24 is in fact 6 times 4. So we got that going for us. The fun fact is way back here on these properties, you were told that the log of a product is actually the sum of their logs. So I could rewrite this as the log of 6 base 5 plus the log of 4 base 5. And then you go, oh wait, this is just straight substitution. What is the log of 6 base 5? Oh yeah, that's given to be A. What is the log of 4 base 5? Oh, look at that, it's C. So lo and behold, your answer is actually A plus C. And that's how you're going to set these things up. So you really do have to kind of think about these numbers in terms of other numbers. So oftentimes we're like, hey, what's 6 times 4? You're like, oh, it's 24, got that. But the reverse of it is like, okay, what numbers make up 24? Well, we all know there's infinitely many numbers that multiply to get you 24. But the ones that are given to us are 6, 9, and 4. So we have to use those. So then we move on down to the next one. And I'm saying, okay, what's the log of 36 base 5? So you look up here and you go, okay, all right, I got you, math dealer. I see the 9 and the 4. And yeah, that makes 36. So I could really rewrite this as the log of 9 base 5 plus the log of 4 base 5. Well, the log of 9 base 5, yep, you know it, it's B. The log of 4 base 5, oh yeah, it's C. And there's your B plus C. Now here's another fun fact. We could have actually done this another way. You know 36 is in fact 6 squared. Nobody's going to deny that. So if I said to you the log of 6 squared base 5, that's the same thing as saying the log of 36. But we also learned that there's a power property here, that this 2 is actually the product, it's actually the coefficient of log of 6 base 5. That 2 could actually flip out here. So the log of 6 base 5 was given to be a, and then my 2 just trickles on down. So 2a is also the log of 36 base 5. So we can actually express these things in different ways using a, b, or c, or a combination of any of them. If you're getting what's going on now, hopefully. All right, so check out the log of 12. And you're like, oh, wait a minute, Diehler, what's going on here? I don't see 6, 9, and 4 making up 12, but you do know some products of 12 that could help us here, right? You know that the log of 6 plus the log of 2 could get me the log of 12, true? The kicker, though, is you're looking at this log of 2 base 5. You got the log of 6 base 5, that's a. We've got that. We're good with that stuff. But the log of 2 base 5 isn't necessarily a 6, a 9, or a 4. But we do know that the square root of 4 is 2. So this could actually be written as the square root of 4. And remember, a half power is a square root. Maybe I should say that again. A half power is a square root. Well, that half power, just like the previous example, can flip out in front. So really, the log of 2 base 5 could be written as 1/2 the log of 4 base 5. Log of 4 base 5, oh yeah, that was given to be c. And the 1/2 is just chilling around for the party. So the log of 12 could actually be expressed as a plus half a c. So it's not going to just pop off the page, all right? And I want to make sure you understand that. Big part about math, and everybody's like, oh, why do we need to learn math, right? Well, the big part about math is that we're breaking your brain apart, right? We're challenging that brain. We're getting it all charged up. And that's really what these logarithms are doing. Think of it like a detective. You're sitting there and you're analyzing some things, and you're like, okay, I see the number 12, but I need to see it a different way. And that's what these logarithms are getting you to do. It's charging up that brain, getting those brain cells going, right? Okay, so now you're looking at this 180. You're like, okay, I get what she's going with. Now, the 180, let's think about that. We know 180 comes in all shapes and sizes, right? We have 9 times 20. Yeah, 9 times 20. Well, okay, that's cool. I got a 9 there. 4, if I can get some 20s out of 4s if I do them 5 times. I think we know that, right? So we're like, okay, well, this is something we can work with, right? But we also know that 36 times 5 gives me 180. So you really just kind of find some factors that you can work with, okay? So as I said we had log of 36 base 5. And I said 36 times 5. So that's the log of 5 base 5. So the 36 times 5, log of 36 base 5. Well, that's, hopefully you're starting to pick up on it. 36 is 6 squared, right? So if 36 is 6 squared, that's pretty cool, because that's the log of 6 squared base 5. The log of 5 base 5, we're going to talk about him in just uno momento, right? So now this 2 can flip on down in front. Check it out. Now I have 2 times the log of 6 base 5 plus the log of 5 base 5. Well, we got log of 6 base 5. Remember, that's a up there. So this becomes 2a. Log of 5 base 5. That's actually an integer. You think to yourself, hey, self, 5, right? 5 to what power gives me 5? Oh, yeah, 1. Just remember, there is that little rule. I wouldn't say rule, but it's a property that says the log of any base with the same base is always going to be 1. Because what base, right? Base raised to what number gives you the same base? Well, it's got to be 1. So the log of 5 base 5 is 1. So I could actually write log of 180 base 5 is 2a plus 1. So hopefully this is starting to make a little bit more sense. And again, got to break these things down thinking about the number in terms of other factors. And I really think that's what's going to get you through all this stuff. Okay? Last but not least, let's check out this guy. Yep, I threw a quotient at you, but you're cool. You can handle it, right? You're tough. Just remember, if I have a quotient, I actually have a subtraction. So oftentimes I'll say to my students, I see division, what do you see? And they'll say subtraction. And that's always fun to say. All right, so I'm looking at the log of 18 base 5 and the log of 1 base 5. Well, here we go again. The log of 1 base 5, that is a number. It's actually 0. Okay, the log of 1 any base is always 0. And now we're going to check out old 18. 18, well, I know who you are, right? You're the log of 9 plus the log of 2. Because, oh, by the way, 9 times 2 is 18. The 9 one we got, right? Remember, the 9 was given to us. That's our B. But the 2, not necessarily, unless you think of the log of 2 as the log of 4 to the 1/2 power base 5. That 1/2 flips out in front, and I'm looking at 1/2 log of 4 base 5. So here we go. The log of 9 base 5 plus half a log of 4 base 5. Well, the log of 9 base 5 we said was B. Hopefully you remember that from up there, right? And then half the log of 4 base 5 is going to be 1/2. And the log of 4, remember way up here, that was our C. And lo and behold, you have B plus half a C. Don't forget though, there's a minus in front of all this. So yep, distributive property in action. And there you go. That's actually the equivalent of the log of 1/18 base 5. Now, I'm not sure, but some of you might have actually thought of 2 other numbers that you could multiply together to get 18. Any thoughts there? So if I have the log of 1 minus the log of 18 base 5, well, 18, yeah, 18 is also 6 times 3. So I could have actually even rewritten this as a log of 1 base 5 minus the log of 6 base 5 plus the log of 3 base 5. Notice I put the minus out front, right? I'm subtracting all of that, what's inside that parentheses, the 6 and the 3 terms. The log of 3 base 5, well, think about that. How can I write the log of 3 in terms of the 6, the 9, or the 4? Well, hopefully you're now kind of getting the hang of this whole square root thing. 9 to the 1/2 power is the log of 3. True? So the 1/2 can slip out in front. Now the log of 9 base 5 times 1/2. And of course the log of 6, he's still chilling. All right, and then obviously from the previous little slide above, right, we can actually say, well, log of 1 is 0 minus the log of 6, remember that was our A, minus, because I'm subtracting all of this, right? Remember that minus is going in. That's that distributive property in action. You got to love it. It's very action-packed. And that becomes 1/2. And then I have the log of 9 base 5. And remember the log of 9 the log of 9 up there was B. So then I get this. So my final answer is negative A, 1/2 B. So either one of these is correct. How cool is that? Very. All right. So that's kind of using the properties, breaking down with letters. The next slides, my next video is going to be on solving logarithmic equations because that's really what these properties are all about, right? We need to break down some logarithmic equations. All right, this is the Math Dealer signing out. Hope you enjoyed the little lesson on logarithms.